Okay, this is your second video on the aldol reaction. And with this video, we're going to kind of work through three examples and see if we can come up with the alpha-beta unsaturated carbonyl products. So these are all reacting with sodium hydroxide, or we can just say hydroxide. And so to begin with, we look at our carbonyl compound. We see that there are acidic hydrogens on the alpha. And so if we react our base with the acidic hydrogens, then we can make an enolate. And so if we draw the enolate that forms, that is our nucleophile. And so we already have a molecule of the electrophile here, and if we show this coming in here, adding onto the carbonyl, then eventually this is going to become the OH, and so we can show if we want pulling off. We're not trying to draw the whole mechanism out in appropriate steps. We're trying to get an idea of what the final product is going to look like. So if we are doing this, then here's our original molecule. Let's number the carbons. 1, 2, 3. And then let's number the carbons in our enolate. 4, 5, 6. So our final product is going to have 6 carbons, and which 2 carbons are going to be stuck together? 5 is forming a bond to 1. And so in our product that we draw, we need to have 5 bonding to 1. So when I'm drawing a product, I'm going to draw the the aldol product first, the beta hydroxyaldehyde, and then we'll dehydrate to form the final alpha beta unsaturated, the one with the double bond in. But I always draw the enolate first, because that's the one that looks most recognizable in the product. So this is carbons 4, 5, and 6. Now 5 is going to be bonding to 1, and so I'm going to draw that down here. And 1 has now a single bond to oxygen. It's got an OH on there. So that's carbon number 1. And then we have carbon 2 and 3 hanging off there. So 1, 2, 3. What we have here is a beta hydroxyaldehyde. So attached to a beta carbon we have the hydroxy group, and then we also have a hydrogen here. So if we lose a hydrogen and an oxygen, an OH there, we're losing a molecule of water, and we can draw the final product. It's having trouble focusing there. There we go. So our final product then is this. And again, if we number it, it'll be clear what is being attached to what. Okay, so we have formed an alpha beta unsaturated aldehyde, connecting those together. So let's try that with a ketone. So another 3 carbon species right here. If we form the enolate from it, then we have deprotonated one side. Both sides are the same, fortunately, otherwise we'd have to deal with 2 different enolates. And if we want to number again, this is carbon 1, 2, 3, and in the enolate then we can number however we want, 4, 5, 6. So in this reaction, the enolate carbon again is attacking the carbonyl, kicking the electrons up there. Again, we can draw our molecule of water, turning this into an alcohol there. So drawing the product then, we have our enolate, which again I always draw first because it's the most recognizable in the final product. And then 4 is now bonding to 2. So there's a new carbon-carbon bond to carbon number 2 here, which now has an OH on it. And it has attached to carbon 2 a methyl group and a methyl group. So we have carbon 1 still attached and carbon 3 still attached. And here we have our couple of hydrogens. And here is our beta hydroxy ketone, alpha, beta, and then we're going to lose a molecule of water and give our final product, which is going to look like this. You're going to have some homework ones to practice, and you'll get better at this as time passes. So if you look at the next one, this could be your first practice if you want to turn off the or pause the video right now, or you can wait for another minute or 30 seconds and then pause it. But let's look at what we have here. We have a ketone that has two different kinds of alpha hydrogens. So there are two different enolates that are going to form from this. We will form an enolate on the left, and we will form an enolate on the right. So we have two different kinds of nucleophiles here, and each of those nucleophiles could react with our electrophile starting material to form a product. So this will be a good time for you to pause the video, number your nucleophiles, number your electrophile, draw arrows, see what's connected, and draw the two products that would form. Okay, so if you've done the work, then this will look familiar to you. I'm going to number here 1, 2, 3, 4, and then I'm going to number here 5, 6, 7, 8. Doesn't matter how you number as long as you do number. Okay, so we're moving this up here so we have a better chance of staying on the page as time passes. And if we're going to react this first enolate then with 5, 6, 7, 8 with our original ketone, then we are coming in, 1 is forming a bond to 6. Drawing the product of that, then I draw first my enolate, which I'm numbering 1, 2, 3, 4. Now I know that 1 is going to bond to 6, and so down here is our carbon number 6, and then attached to it is 5, 7, and 8. So 5, 6, 7, 8. And I can either draw this OH in here and the H here and lose water, or maybe now I've gotten to the point where I know where I'm going to form my double bond here between the alpha and beta, and just go ahead and draw the product. So that's one product that will form in this reaction. And the other one then, if I'm numbering, I'm going to number this the same way, 1, 2, 3, 4, and number my electrophile the same way, 5, 6, 7, 8. And I'm going to draw the product, so I'm starting by drawing what was the enolate there. 3 is going to form a bond to 6. And so 3 is coming down to carbon number 6 right there. Then I have 7 and 8 over here and 5 here. So 5, 6, 7, 8. And here's my original alpha carbon. Here's the beta, and the double bond forms there. So we have some problems in your book that you can, or that you should work to give you the practice that you need. And that's chapter 23, problems 3 and 4. You're drawing products of an aldol reaction of several aldol reactions in those. And sometimes you'll get one product. I think in the number 3, there's 3 different ones, and you'll get one product for each of those. And then number 4, you're going to end up with 2 different kinds of products because you'll have formed 2 different enolates. Make sure you practice this because your puzzle tomorrow, your Thursday puzzle tomorrow on Wednesday, is going to be applying your aldol reaction in a new and interesting way, but you need to have the background, you need to have the practice drawing products of aldol reactions.